Hello, folks. Welcome to another in the series of shorts brought to you by Bristol Ground School. My name is Andy Sinclair. In this video, I'll be looking at the basic properties of a gyroscope. So let's start right at the beginning. A gyroscope is simply a disc or mass that is caused to spin or rotate around an axis passing through the middle. It is the fact that it is rotating that makes it a gyroscope. If it isn't rotating, then it isn't a gyroscope, or at least it doesn't exhibit the properties of a gyroscope. The word itself originates from the Greek gyros, meaning round, and scope, meaning to look. Let's have a look at this animation. Initially, we see the disc with a rod having two pointed ends stuck through the middle of it. If we try to erect this with our phantom finger, then it simply topples over. This is as we would intuitively expect. However, suppose we were to spin the mass in a horizontal plane of rotation around its vertical spin axis. In that case, it becomes a gyroscope and remains rigidly erect until the spin rate of the mass slows, and of course, the gyroscope topples again. This leads us to the first of the gyroscopic principles, rigidity in space, sometimes called gyroscopic inertia. A spinning gyroscope will maintain a constant attitude in space. This means that the gyroscope has the useful property of acting as a reference plane. This is particularly useful in aviation in situations where we have no external reference, i.e. when we're flying in poor visibility or cloud. The second useful property of a gyroscope is less intuitive. Take a look at the next animation. In this animation, the mass is mounted in a metal frame called a gimbal and has a vertical plane of rotation, turning in a counterclockwise direction around a horizontal axis of rotation. Now, if we prod the left-hand side with our phantom finger, then it isn't the left-hand side that moves as we may intuitively expect. Instead, the bottom of the mass moves away from us. Another more formal way of saying this is when an external force is applied to a mass of a rotating gyroscope, then the effect of the force is seen to act at a point which is 90 degrees further around in the direction of the vertical plane of motion of the mass. In this animation, the vertical plane of rotation is counterclockwise. Hence, when the force is applied to the left-hand side, the force is seen to act 90 degrees further around in the counterclockwise sense at the bottom of the vertical plane of rotation. This is known as gyroscopic precession. In order to help us understand gyroscopes, it's necessary to define some terms. The plane in which the mass is rotating is, not unsurprisingly, called the plane of rotation. And the axis around which the mass spins is called the spin axis. The frame which supports the gyroscope axis is called a gimbal. If the axis is mounted in one gimbal, then it will be able to move in one plane, and it will be said to have 1 degree of freedom. If the axis is mounted on a gimbal, which is itself mounted on a second gimbal, then the gyroscope will be able to move independently in 2 planes. It's said to have 2 degrees of freedom. Rate gyros are gyroscopes that have 1 degree of freedom. Space gyros, also known as free gyros, are gyroscopes that have 2 degrees of freedom. A gyroscope is said to be tied if one of the gimbals is physically connected to the aircraft's horizontal or vertical plane. Now, let's have a look at how these definitions and descriptions apply to this animation. The gyroscope here has 2 gimbals and thus 2 degrees of freedom. The spin axis is initially horizontal and the plane of rotation of the mass is initially vertical. To demonstrate one of the gyroscope's 2 degrees of freedom, the axis of rotation moves from the horizontal through the vertical twice before returning and settling on the horizontal again. At the same time, the plane of rotation is initially vertical and moves through the horizontal twice before returning to the vertical again. Lastly, this gyroscope at the end of the video turns whilst the plane of rotation remains vertical and the axis of rotation remains horizontal, demonstrating the second of its 2 degrees of freedom. I hope you found this useful. Next time, we'll look at how gyroscopes are used in instruments to keep the pilot heading in the correct direction and the aircraft the right way up. Cheerio for now.